We now are testing the ducting system in the basement, and we had some video of the test on it previously. Just like the system upstairs, we're going to use our digital manometer hooked to our duct blaster system. And as I turn this on, I want to set the mode. And for those of you who might get into using this, you want to set the mode so that you go from pressure and flow. We have two channels. We have an A channel and a B channel on the digital manometer. And I want pressure in this channel and flow in this channel at 25 pascals. Okay, so let me hit the mode, and you can see right down here, you probably can't see it very well in this camera situation, but it's going to pressure flow at 50, pressure flow at 25. So the duct blaster measures as a standard measurement the pressure in the ducts at 25 pascals of positive pressure. Previously, my recollection is that we could get it up to about 9 in this particular ducting system, and we've done some sealing. This is a much bigger ducting system than the one in the auditorium. It has less connection to outside, perhaps, because it doesn't have as much framing, but it also had some problems. So we're measuring pressure flow at 25. We're going to change our device from the blower door over to a duct blaster B. And what I'd like to do is kind of set up, I've got my fan cover, the little shower cap fan cover on the fan right now. And I want to see what's happening as a kind of a baseline in this system. So I press the baseline button, and I'm going to start getting some readings and see what is happening, if it's registering a negative or a positive pressure in the system. Not so much for data recording, but just to learn what it's doing. So I'm going to watch this for a minute. Go on. So we've let the manometer have about 40 seconds now to measure a baseline, and what it's showing is that there's kind of a positive pressure of 0.1 pascals, which is a very, very minimal reading. So we'll enter that data and we'll go with that. And what we're going to do now is remove the shower cap and see if we can crank this up to 25 pascals and see what we got. So here goes the shower cap. And here goes the duct blaster. And we'll see how good we can get it. Well, you can see that we've gotten up to 10.6, which is not a huge improvement over what we had before. And we're reading at about 1,540 CFM 25. So I'm going to turn this off. I want to write that down, 10.6, 1,540. Now, what I could say about this ducting system, this is a much bigger, much longer ducting system. It covers at least 3/4 of the building. And as the trunk lines for the return on this building run the full length of the building, they connect to building cavities in the attic that are essentially 2x4 or 2x6 attic rafters with metal panned over them. Underneath that panning, we have areas where there are light fixtures mounted into that system, where there's wiring running through it. There are just so many places in that attic that were underneath previous existing insulation that we would have had to find to actually seal it. We didn't get as good a sealing as I think I would like to have seen in this particular case. We've reduced it some, yes, but not as much as I wish we had. So in this particular case, we didn't get all the reduction that I'd hoped for. I regret that we didn't get it tighter, but really that kind of tightness is something that should be done when the place is being built. We found this hole in our duct testing equipment, and we're concerned that this hole could have a pretty substantial effect on our readings. So we want to actually tape this off and see if we get a better reading with this hole sealed. I think that might do it. What do you think?
Yeah, let's try it.
Got to 11. It's bounced up to 11 and 15, 20. So just taping up this little hole that we found in the test equipment took us from 10.8 to 11, from 15.4 to 15.2, or 1540 to 1520. And when you think about all the leaks down here, for example, if we look at these drive connections, every one of these is a leak. And we look at the crimp connections like these that where the crimped pipe fits inside of a flat pipe, every one of these is a leak. So we really have, there's more opportunity to seal leaks in this system, not to mention the fact that as this supply system connects to the slab floor of the main part of the building, these ducts run through concrete slab floor under the building that over the years has probably cracked. And we probably have a lot of leakage in that concrete. So just when you realize how this little tiny leak in this testing equipment made a measurable difference, there's just so much leakage in these systems that's just built in that it's extremely difficult to get to it all.